Oh, now we get to chapter 10, and up to this point, if you thought you were confused, that's it. You only thought that you were confused, because now we get to talk about hypotheses. Ah, Lord. This stuff isn't hard, but they have to make it sound hard. Okay? And so it drives me batty trying to figure out sometimes what these statistical buggers are thinking. Okay? Why they have to make it sound hard, I don't know, but they do. Okay, and I'll give you some examples, I guess, as we go through this. But what we do, and let's start with number one. It might be easier just to explain that, right? Which is like your number two. A sample of 36 observations is selected from a normal population. So we're taking a sample, right? Sample mean is 49, so we've done the math and found out that our sample mean is 49, and the population standard deviation is 5, okay, which is given to us. Conduct the following test of hypotheses using the 0.05 significance level, or of course the 95 significance level, I guess, in that sense, right? Okay, so what are we doing? Well, okay, you're gonna get to get used to and get tired of seeing these things, right? So our hypothesis is, let's see, it says conduct the, well, it's giving us this, okay, so we're going to worry about how we establish or how we come up with these in the future. So for now, let's not confuse that issue. So our hypothesis is that H sub O, though, is that mu is equal to 50, or the mean, in this case the population mean, is equal to 50. Okay, remember our mean of our sample was 49, and then the hypothesis, the alternate hypothesis, is that the mean of the population is not equal to 50. Okay, so here we go. Let's do some stuff. First, let's put down all the information that we have. So our mean of our sample is this, okay, right? 49. Our sample size is 36, okay? Our significance is given to us as 0.05, and remember the opposite of 0.05 would be 0.95, or the complement of it. The mu that we're looking for, that we're testing, is 50, okay? Our standard deviation is given to us at 5, and remember, this is an oddball one, so pay attention. I guess for 330 it says for exercises 1 through 4 answer the following questions. So there's A, B, C, D, and E for each of these, right? 5 different questions that we need to answer for each of these. The first question being, is this a one or a two-tailed test? And it does say, doesn't ask why, I guess, okay? And the answer here is that it's a two-tailed. And what we'll find out, and what it tells us probably in here, is that when we've got an equal sign, okay, if we're testing whether something's equal or not, it's a two-tailed test. What's a two-tailed test mean? Well, let's go back and look at our little chart thingy here, okay? A two-tailed test means that we're testing really whether something's going to end up, in this middle part somewhere, depending on our level of significance, right? Okay. And if it doesn't, then then is it possible that it could be on the ends out here? Okay, if it's a one-tailed test, that's going to be more like we would test here. Is it possible that it could end up out here? Okay, this is maybe the area that we're testing, but is it possible that it could end up out here? Or what are the probabilities that it could end up out there? It's kind of what we're testing. So this is a two-tailed test just because it says equal. Okay, and B, then, what do? Well, by the way, this one's called the null hypothesis, and this one's called the alternate hypothesis. And I couldn't get an H sub 1 there for some reason. So I don't know why the heck I couldn't get an H sub 1, but it's a pain in the butt trying to figure these things out anyhow. So this should say H sub 1, or my alternate hypothesis, right? So we reject the hypothesis if it's outside the central area, right? So all we're saying is that we're going to reject it again if it's outside of, say, this area here, okay? And based on the level of significance. And let's go take a look at that, okay? So my level of significance is 0.05, okay, or 95. And remember that if we divide that in half, the 95, we get up to 0.475, and that's, you know, it's something that we're kind of used to, right? So, you know, 47.5 is what I'd be looking for as a percent then, right? Boom, right there, okay? Oh shoot, I should click on that. All right, so my z is equal to 1.96, but remember, we're going to test whether it's in the central part, so it's either plus or minus, because we can come all the way down here, right? So we want to know if it's in between here, plus or minus this 1.96, because it's a two-tailed test. Okay, and we want to be 95% confident that it would end up in there, is what we're saying when we have that significance level. I'm sorry. Okay, so how do we do that then? Here's our formula. It looks like a relatively straightforward formula. Put this information though again. Okay, our test, or the z that we're looking for at this significance. I probably should have it right below there, but it's plus or minus the 1.96. So here's our formula. Then we're going to calculate a separate z value. We're going to use this formula to calculate a separate z value and then just test it or compare it to this z value based on our significance. Okay, and that formula is simply saying that it's equal to our mean of our sample minus the mu, okay, which is what we're testing basically, okay, divided by the standard deviation, divided by the square root of n, or, you know, this is what standard error of the mean, the bottom part of this equation, standard error of the mean. Okay, so I think I broke the equation down here, and I said that first we got it's equal to our mean of the sample minus the mu, or the mean that we're testing, okay, is minus 0.1. And then I've got the standard deviation, which is 5, divided by the square root of n. N is 36, so the square root of that is 6, if I'm not mistaken. So really this is 5 divided by 6. Okay, but we can do it a little bit the longer way, because it won't always be that easy. Divided by the square root of this number. Okay. So I get 0.833333, but it's my minus 1 then divided by that, right? So it's my test stat is equal to this divided by this. Okay, so now the question is, okay, I came up with a minus 1.2. So does that minus 1.2 fit in between the minus 1.96 and the plus 1.96? Well, you know, let's see. Here's my minus 1.96. Okay, and so I can go all the way from there over to here, and I just want to know if that minus 1.2 fits in there. Well, sure it does, right? Because here's, you know, it's right about here. Boom. Okay, so it fits in there. You know, it's getting kind of closed out here, but it fits, right? So what do I say then? Well, I can't say that I accept the null hypothesis. I have to fail to reject it. Okay, I fail to reject the null hypothesis. Get used to that language. Okay, so, and what's that mean? That means that there's a pretty darn good likelihood that a population mean of 50, right, would be consistent with a sample mean of 49 at the 95% significance level, or 0.05% significance level. Okay, so what do I do then? So D had asked me for, you know, what's your decision? So I failed to reject. And then it asks, what's the p-value? Okay, and I didn't label this as p, but I should. So what do I do there? Well, what I'm going to do is turn my test statistic kind of backwards, right? Okay, and so I'm going to take a look at my my z value in the chart, this minus 1.2, so remember that, okay? And for you guys, you might want to use the book, but you can do it here, minus 1.2 or 1.2, because I don't have pluses or minuses. Remember, it's going to be the same on either side. So 1.2 is 0.3849, 0.3849. So I put that in there, right? I looked that up, and that's equal to 0.3849. Okay. Well, okay, that then is right here because I got my minus 1.2. Okay, and my plus 1.2 would be 38.49, and so that's kind of where that stuff falls, or where it's good likelihood that that's going to fall. So I want to find out then what's the probability or the p-value then of it being outside of that. Well, you know, I got 23.02. How did I come up with that? Well, let's take a look. Let's go, let's start here. Okay, and again, it was minus 1.2, right? Oops. Oops, I'm going the wrong way. Let's go back this way. There we go. So 11.51. Okay, so I'd have 11.51 from here to here, but I'd also have 11.51 up here then too, right? If I came down here from 1 to 2, and I can do that. Okay, just to show you. Oops. 11.51. So, you know, 23.02, something like that. Okay. So, you know, you do the math, right? The other way to do that is say that it's equal to, okay, 2, because I got a two-tailed test, right, times, parentheses, 0.5 minus this number, right? And it comes up with the same thing. So, and what that means is that there's about a 23% chance, 23.02% chance, if you want to be official, of finding a value outside of the z value. Okay, outside of this z value. There you have it. Again, kind of complicated, and it gets worse. So, hang on.